Bob Butler heard about the Vesalius project. He visited us with a Glaxo representative, and we showed them the results of the Vesalius project, and they were convinced that this work could be extended to model the entire human body.
And that program was
when we identified these resources, we pulled them together, and Butler Communications pulled them together and created the Virtual Anatomy team.
The Virtual Anatomy project started out as an anatomy project in the sense that a couple of anatomists, Tom McCracken and I, and some other of our colleagues, thought that with the evolving ability of generating high-quality computer graphics, we could use this as a tool for teaching anatomy.
I had a vision about what I wanted to see at the end of this. I really had a very clear vision of what I wanted to see in this. And I had really no idea how we were going to get there because I totally didn't understand the algorithms and the difficulties. As we moved along, I got to know this.
Well, I'll tell you, that's how it started. There was a couple of anatomists who knew a little bit about computers and not too much, trying to do some anatomy on a computer.
It became apparent very soon that there were no readily available programs that would simply enable us to take human anatomy images, plug them into a computer, and turn them around and dissect them and do the things we wanted to do.
And they were smart enough to realize that instead of trying to acquire the expertise on their own, they should enlist some help of people who knew what they were doing on this side of that side of the aisle.
It looked initially like, well, perhaps we could work something out here, but eventually it became a marriage made in heaven.
So then we had a mathematician and a computer engineer, programmer, an engineer, two anatomists, medical illustrator, no plumber yet, but in every meeting, which we had a weekly meeting, we started to kind of gel about what we could do and what we couldn't do.
And that's why I was wondering if they should be careful when they get you a texture so that you wouldn't have to...
I'm going to have to change a lot anyway.
And this mechanism has proved very beneficial for facilitating the communication between the various members of the team.
So what's the date? Let's get the date on this. When will we have it done? By the end of the week, possibly?
This project requires so many different skills and so many different backgrounds and so many different technologies that if we didn't maintain this diversity, we couldn't deliver this product of these models of the human body.
We're not worried about quick freezing.
Everyone is bringing something very important to the table when we get together, and we all know that, and none of us could do it alone. So it would be difficult for us to do it with one member missing. In fact.
Exactly
what about the tongue? We're just going to take a picture of
tongue.
your
We're
tongue?
just going to take a picture of her tongue, yeah.
Whose tongue?
Block it on the surface. I think Dan has a wonderful tongue.
Dan has a great tongue.
As long as he brushes it close to...
Dan's tongue is a lot like a human being's.
We have really come up with an excellent team that functions extremely well together.
Tom McCracken, of course, and I have the role in terms of knowing what we want to see on the computer, but it really took the engineers and the mathematicians and the computer scientists to get to the point where we had something to look at.
The expertise, the resources, and the team were in place. Now there was a new challenge. How do you get the enormous amount of data needed to build a computer model of something as complex as a complete human body? How better than from the real thing?
The University of Colorado Health Sciences Center operation, which is directed by Vic Spitzer and Dave Whitlock, have the capability down there of freezing anatomical objects and then photographing them as they are sliced.
And when Vic and Dave came along with this unique cutting process, our world just opened, because now we could see everything, because we were looking at the actual anatomy that's been cut through with a sharp saw.
The section of a cadaver that we extract, we then embed it in a gelatin ice mixture and end up with this ice cube, which we then plane slices off of, or plane surfaces off of, and just keep taking picture after picture after picture.
They're the only people that can cut large specimens very accurately and store the cross-sectional images as high-resolution color photographs, which is our starting point.
They were willing to work with us and cut the thoracic region, chest, of a human male cadaver that we could use for the virtual anatomy project. This is a very quick cleanup because it's all dry, it's all microscopes, most of the tasks involve moving.
Tom Spurgeon is an anatomist by training, and he teaches anatomy courses here at the university.
And one major goal of this project all along is to improve anatomy education. So the project would not be what it is without having someone on the anatomy education side of the project.
Tom is probably noted as the best anatomical instructor at CSU. He's been for years and years.
Fluid cause proteins to link together. That's how you preserve the tissue.
He's our main resource for anatomical issues of all sorts.
Oblique fissure, but there should be a horizontal fissure as well.